In this video, we will look at troubleshooting TAM7 blower communication faults. The goal of this video is to demonstrate how to identify a blower communication fault, how to verify the low voltage circuitry, how to verify the high voltage circuitry, how to verify the blower motor, and how to perform a go, no-go test. Identifying a blower communication fault. A 4-flash fault code from the airflow control board's fault LED signals a blower communications error, and there are a number of steps involved in troubleshooting this condition. Verifying the low voltage circuitry. Begin by verifying the blower wiring harness is securely plugged in at J7 on the AFC board. Next, verify that there are approximately 13.8 volts DC across the red and black leads on the low voltage side of the motor. If you don't have approximately 13.8 volts DC, check the source on the AFC board at plug J7, again across the red and black leads. If you do not have power at plug J7, remove the plug and check the pins on the board directly. If you still do not have power and the TAM7 is powered up with the LEDs on, the AFC board may be defective. If you do have power on the AFC board but not at the blower, check continuity of the wiring harness by removing the connectors at both ends and ohm the leads. Go ahead and check the continuity of all 4 leads, the red, green, white, and black leads. If any of the leads are open, trace the wiring through the 10-pin connector located in the coil section of the unit and repair or replace as necessary. Verifying the high voltage circuitry. To verify high voltage circuitry, power down the unit and remove the blower panel. Disconnect the high voltage plug at the blower motor. Set your multimeter to volts AC and insert the meter probes into the red and black leads on the door switch side of the wiring harness. Power up the TAM7 and manually close the door switches. If your meter does not read approximately 230 volts AC, refer to the wiring diagram on the inside of the blower panel door and trace back the high voltage wiring. Verifying the blower motor. With the TAM7 powered down and the blower panel removed, verify that the blower fan spins freely. If it does not, make sure that rotation is not restricted due to improper mechanical alignment, debris, or other foreign objects. If the blower fan will still not rotate, the motor must be replaced. Performing a go, no-go test. If you have verified low and high voltage power at the blower motor and all leads ohm out, then there may be a problem with the motor itself. To verify, perform a go, no-go test. Now, it is recommended that you perform this procedure using a serial motor diagnostic go, no-go test harness, available through publication number 34-3454-01. With the TAM7 powered down, disconnect the low voltage plug from the motor and connect the test harness. Remove the low voltage leads from the transformer and attach one end of an alligator clip to each of the 24-volt AC terminals. Attach the other end of the alligator clips to the red and blue leads of the test harness. Power up the TAM7 and manually close the blower door switches. If the motor does not run and you have verified high voltage to the motor, then the motor must be replaced. If the motor does run and wiring continuity has been verified back to the airflow control board, then the problem most likely is with the AFC board itself. Replace the board and retest. If the problem persists, install a new blower motor and test it both with the old AFC board and the replacement AFC board. This concludes this demonstration of troubleshooting TAM7 blower communication faults. Please refer to other FieldTechHelp.com videos as well as TAM7 technical documentation for more information and additional troubleshooting procedures.